And this is Dallas Personal. Oh, now we're recording. So welcome, everybody. Today is the 23rd of July, at least in these parts, Dallas. And this is the Dallas Personal Robotics Group. We'll do the usual thing, go around the table, talk about our projects and questions and whatever random semi-robot adjacent related things that we have. There's just a couple of minor housekeeping things. So last weekend on the 20th of July, DPRG participated in Moon Day, and at least John Kay has some photos, and maybe some other people have some things to talk about. And then coming up this coming Saturday, the 27th of July, we have our monthly meeting, which will just be a gathering and swap meet. Pizza for those that can make it in person. And
Carl, can I ask a question related to the upcoming monthly meeting?
Go for it.
I just want to check with John Kay whether you're going to be there, whether you will be able to be there at the start of the meeting
I'm
or
to be
before
there.
the meeting, so that.
Yep.
Okay, great. So you'll bring the DPRG doorbell.
Everything's in order. So, yep.
Great. Thank you, John.
Cool.
Carl, we also have it on some pictures on the web. I don't know if you know that.
I'm not aware of it, so why don't we, if there's no other like general housekeeping stuff, why don't we let John Kay start it off, and then Doug, maybe if you wanted to throw in some photos.
Just flip a couple of, go to the news. It's easy.
All right.
Go to news.
I guess since I'm sharing already.
Yeah. Now slide down.
Oh, look at that.
There's even a little video.
A video, very nice.
Not much, but.
And for those that haven't been to the Frontiers of Flight Museum, it's pretty cool. They've got some nice items on display.
Yeah.
50th anniversary. Oh, Iron Rain. Wait, Kareem, your team's got quite the display going on. Was that the tallest? That looks
tallest
like
banner.
Yeah.
We win. Tallest banner.
Towering over everything but the built-in ones. Oh, we make a good effort with this one though, didn't we?
Yep.
Okay.
Put on the video. It's only
All right.
30 seconds.
All right.
It'll show you the whole thing.
That a good crew representing. That's a lot of robots.
There's Mike.
Oh wow, Iron Rain brought the whole arena.
Mm-hmm.
Very nice.
Yep. I think it was a very, very good effort by the club. A lot of everybody really pitched together to make a good presentation.
It was a very good representation.
That sounds
Okay.
great.
I'll show you more pictures. I have a slightly different set.
And was it decently crowded? Were there interested parties coming by?
So I also include, of course, they have a model of the Saturn in that, so they have that. And there's one of theirs that they ran in the course. And then there's that monitor where you had the pistols. You had different things there. You can see yeah, that they would run their own robots and have rings that they would put up on the rack there. So that was part of their object. And then there's sort of the hangar, sort of a bigger view of the hangar. An overview. Okay, and that's a little bit video there. And this is a composite sort of the circle. So, upstairs, somebody had one of the colleges, they were showing this that they had. And then, of course, we had like 3 of the robots were remote control where people could run, play with them, and try to get the can and stuff like that.
Oh, cool. So Eric was letting people drive his robot around.
Yeah. And there were other things like telescopes there. Yeah, okay. And that's
I
it.
like Eric. I like Harold's display.
Yeah, that was cute. So yeah, that's why I snap a picture of that. Had, of course, our thing. So that's what I have picture wise.
Very cool.
Thanks for taking those pictures. A lot of us remote people were curious to see them.
Yeah.
Yeah, my little ball robot was a big hit. I let all the kids drive it around.
Oh, yeah?
I realized, at 2 or 3 years of age, they don't really know how to drive a robot, but they end up grabbing it and throwing it. So it's like, oh. But it seems, I hate to say indestructible, but it got thrown a few times and it was fine.
So is that good practice for your your immersive theater?
Yeah.
Nice. Any other pictures or thoughts from Moon Day? You guys psyched to do it again next year? Those who went.
Well, thank you very much to everyone that participated and made it happen. It was a great show, a great showing, and like Doug has been saying, this is the year that we're getting fully back in the swing of things after COVID, and this was a part of it. So thank you to everyone that participated in that.
Cool. I think next in line, Mike, you had some, would you call it progress or sideways movement or questions, or what would you call it you got?
Well, basically have been stuck on trying to figure out how to get serial port access. And well, I was going through my since I'm running ROS and I got a Raspberry Pi. Pi doesn't do well. ROS Humble and what's the next one? But it requires Ubuntu 22.04, and it doesn't run natively on the Raspberry Pi. So I got the Docker thing sort of working. And then I tried to say, okay, well, if I go to the newest ROS, which is what I like to do, is just it's going to be out of date soon enough. So if I go to the newest one, it actually runs on Ubuntu 24.04, which is what runs natively on the Pi 5. And so I made a Docker because that's what Docker's for, is to experiment, I guess. And then I realized that I couldn't open a Python serial port, and that ran me down a big rabbit hole. Yeah, because basically PySerial is not available in Ubuntu 24.04. I don't know why, but it's just not there. Maybe it just hasn't caught up or something. So I've been running down rabbit holes trying to figure out how could I run it on 2404 and run natively? Because I know if I go Docker with all this hardware and stuff on a robot, it's going to bite me somehow. It's just inevitable, I think. So I was going, oh, well, I'll try that. And I found a couple ways to do it. Basically, I was saying, well, if I go to C++, I can just use a serial package. But it's really hard to find a serial package. But I did find a ROS serial bridge. I don't know if it works on 2404, but it's basically a ROS package, and it says it works on the newest Jazzy, which means 2404. And basically what it does is it connects to a serial port, and then it sends a ROS topic into the ROS operating system. So that would work. And then just today, like an hour, half hour before I logged in here, came online, I realized this is Linux. All serial ports are files. So you can basically open the serial port as a file and read and write it. That should work. So does anybody have any thoughts on this?
Is this running on a Raspberry Pi, did you say?
Well, I'm going to run it on a Raspberry Pi, but I've been just experimenting on my Linux PC.
Right. So, and what are you plugging into your Linux PC, into the serial, like I assume some kind of USB thing?
A USB thing. So
I mean, if you're running Ubuntu, it'll be /dev/ttyacm0 if you don't have any other serial things plugged in.
Right. Yeah.
But why can't you just do like pip install PySerial?
It doesn't work for 2404. It worked for 2204, but it says basically the package isn't available for, they can't find the package for 2404.
There's also a note where it's misidentifying the serial ports on 2404 because of a change of the name in the file system with the kernel. So it's looking for system-base.
Yeah. Well, I didn't get that far along. I just found that PySerial didn't work. So I was trying to find a workaround for PySerial.
Just very quickly, I'll put a link into what I found for identifying the serial ports.
Because in 2404 I was able to see the serial port TTY-ACM0, but
so this is where PySerial wasn't able to find the ports. You're saying you're not able to install PySerial.
Right, on 2404. Yeah. It was my Docker version of 2404, so maybe it's corrupted. I haven't tried just a plain Jane 2404. That might be another issue, but the Docker image for 2404 with a ROS Jazzy package couldn't find it. So there's a lot of variables, complexity that could be screwing me around, but yes. One thing I want to do is put 2404 on my Raspberry Pi and see how it works. Maybe it works a lot different than a Docker image from ROS of 24 with Jazzy and Ubuntu 2404 as one image. Good. Oh, even, yeah.
So if I understand you correctly, you're running 24 inside of a Docker container, and when you try and do sudo apt-get install PySerial, reinstall PySerial, whichever, you can't find the package.
Right. Inside the Docker file. Yeah.
Right. So that speaks to the the Docker image that you're running doesn't have the correct repos configured in it.
Yeah, I couldn't figure out how to change the repos in it either. So I don't know.
So did you try to do a pip install PySerial? That's the part that's not working?
Right. Inside the Docker file. I haven't loaded a native 24/4 image on the Pi. I should probably do that. just to get rid of image issues and stuff like that.
But you haven't tried
Docker.
a straight up interactive install in the running Docker.
I could do that.
You're trying to do it in the Docker file, and you haven't tried it in the as an interactively from from the command line inside the running Docker image.
I can't remember if I tried to run a plain 24/4 Docker image in interactive mode, but I ran the ROS, which included 24.04, but maybe something's wrong with it. Yeah, so it's a bunch of things to try, and it all takes time. And I haven't gone down every rabbit hole, but all these suggestions are good. You know, it should work is the whole thing, and I don't understand why it doesn't. But it might just be something simple like that image is corrupt or just not complete.
Have you
What-
been able to install the Python packages?
Likely, okay,
Have you been
Docker repos should be
able to install other Python?
Oh yeah. Other Python packages work fine. Yeah, like other pip installs work good.
Docker images in pretty stripped down. So you tend to have the build Docker image.
Yeah, includes. Yeah, the Docker file has a lot of includes to get things working the way I want it. The pip install PySerial is what didn't ever work.
Do it interactively is logged into the Docker from a shell container, and then you can interactively add repos to the app to the whatever pip uses for tracking its repos.
Yeah. To run ROS, I have to have interactive, so that ROS image with the Ubuntu is running interactively, and before I run a ROS command, I can do all the other stuff, and it still doesn't load. So yeah, still can't find PySerial, or the pip can't. But pip can find other interesting packages. But yes, so one thing it's been on my mind is to just make a Docker image for 24/04 and desktop, and that shouldn't have a lot of stuff in it. So if it shows up there, then I know that the ROS image is not complete. And I'm not sure how to add the repository to a ROS image. But another interesting thing is that ROS package for the serial bridge, it uses the lifecycle nodes, and so it got a little complicated too. And it's in C, and oh well. So I've been learning lots of stuff, things I didn't need to know, but yeah, I'm learning stuff. So that's sort of where I'm at. I appreciate the inputs.
Cool. Yeah, thanks. It sounds like you'll have a good training after all this is said and done. How to.
All right.
Cool. All right. I think next in line, I think Pat, we had you for later on, and we've rapidly reached later on.
Okay, well, I don't know. It's a simple problem, then I haven't found a solution. So I have a linear shaft with a bearing, and I am trying to drill a hole perpendicular through the shaft. And no drill bit that I have has been able to touch the shaft, basically, to do anything with it.
That's probably a hardened steel shaft, right?
Yeah, so a carbon steel shaft. I've ordered.
No, hard. It's also hard.
Probably hard.
Yeah.
I've ordered some cobalt drill bits, and I'm going to give that a try. So grinding a flat spot and then try to center punch and drill a hole that way.
So the question is, do you have to, for your application, does the shaft have to be as hard as it is right now going forward?
No.
Right on the tip. And are you able to slide that? First of all, can you get the you can get the shaft out of the pillow block, right?
Oh, definitely. The pillow block is
Okay.
Yeah, that just comes out. Bang.
So if you don't need so I assume you're trying to put in some sort of retention pin or
100%.
something like that. Yeah.
Like you guys aren't familiar with I don't know, maybe your lawn tractors have them. These little round retaining pins.
Yep.
They flip open and you drop them through the shaft.
Sure.
And they go on my little tiny wheel.
Right. Yeah.
What diameter is the shaft? Or sorry, the hole that you're trying to drill?
I'm trying to drill a 7/32 hole.
Okay.
So I would suggest you take a torch to it.
Okay.
Heat it up and
Heat it up cherry red? Heat it up cherry red.
and let it cool as slow as possible.
Okay.
And you will anneal it in that region that you heated up to.
Yeah,
parts of it. Pardon?
I only need to heat up the last inch to drill that hole.
Right. Yeah. So you can anneal it. It'll the color will change and you'll have a temper spectrum on it that you'll see. But the end that you and you might need to let the torch linger on it. You really want it to cool down as slow as possible. And because you don't want to heat the entire shaft, the rest of the shaft will pull some of that heat away.
Okay.
But you typically also wrap the shaft in a damp cloth where you don't want the heat to go past.
Okay.
Does that make sense?
Yeah. So if I wrapped all except the last 3 inches.
Yeah.
And then with the 4 shafts and wrap them in a wet cloth. And then use an oxyacetylene torch. And
I wouldn't put the acetylene. I would be careful about that because that's going to cut it. You don't need that much heat. I mean, you could do it with propane or MAP gas or.
I've tried with propane. I can't get it hot enough.
Okay. Yeah. That all depends on how much energy, how big your torch is, I guess.
But if you little solder torch thing.
All right. Well, if you want it, oxyacetylene on a big broad flame will do the trick.
A broad flame, not cutting, just heat.
And low oxygen, and you'll definitely be able to heat that puppy up, and that'll anneal it and make it easy to drill.
The other thing you can do that's a whole lot easier is to take an angle grinder and put a flat on it, and that will both heat it up and give you a better surface to use the drill on. And because often those things are only case hardened, they're not really hardened all the way through. It's just the outer shell. So if you take an angle grinder and cut 1/8 of an inch off of, flat on that gives you a nice flat surface to try and drill through.
Well, I can give that a try. It's easier than the oxyacetylene because I got to go find somebody with a torch, like a hotter than my propane torch.
Or you
Yeah.
could try to
Uh,
avoid the whole situation and do something else like a clamping collar or something.
I can't.
Oh,
So, because when you build a heavy robot and you need to be able to move it by hand, if it's clamped with a collar, you got to take everything apart to move it. So if I use some of these pins, so what I have is on both sides of the wheel, I have a couple of retaining collars, and so if I pull the pin out, it'll freewheel on there, and then you can just drag it along.
yeah, I gotcha.
So I thought of something while I was listening. Have you ever heard of a C clamp? And it's not the kind that you clamp down with a screw, but it's a flat clamp that slides into a slot. And I'm not mechanical enough to really know what I'm talking about, and maybe somebody does. But it's a little flat washer looking thing with an open end, and you slide it around a round thing in a slotted hole, and it kind of expands a little and then clamps down on the hole. Does that make any sense to anybody?
Yeah, you got to get a nice round cut in the end.
Yeah, that's what I
Right.
was thinking. A
And
cut would be easier than a drilled hole.
you can do that with a Dremel, but it's hard to make it really accurate without actual machine tools, like putting it on a lathe or something.
Or
Yeah, well,
use a different shaft that's not hardened.
Yeah, well, I'd have to try to find a shaft that
Yeah.
would fit the bill. And I already got some flange bearings and pillow block bearings and shaft collars.
Speaking of the shaft collar, you can use that as a drill guide just to get the hole started. Usually they have 2 set screws.
This one, it only has one. It's split on one side.
Oh, okay.
That's the clamping collar. You can also get the set screw kind.
Yeah. And you can use that as that, one of the holes as a drill guide. That way you can at least get it started. And
oh, I see what you're
once
saying.
you have a little dimple there, the other drill should follow it. The right size drill.
I do have a sprocket with a set screw.
Yep.
But
That's another idea. You can that sprocket has a keyway in it.
No, it doesn't have a keyway.
Oh, it doesn't. Okay.
It will have a flat spot where the set screw goes.
Oh, okay. Yeah. You can actually I've done that before. You can actually take a sprocket, weld it to the wheel, and if you want, it's a little less elegant than your pin solution, but you can pull out the keyway and it'll just rotate on the shaft. And then when you want it locked to the shaft, just stick the keyway back in.
Yeah.
A little less elegant, but
I just thought the little clips were a very quick way. If I throw a handle on one end,
yeah,
like a pull handle, you pop the 2 wheels that stay on the ground out, and you can just drag it along, and makes it super easy to move without any tools.
Yep, just pull it and move it.
But a lot of good ideas. The torch idea.
One other idea, if you threaded the end of the rod, and that may not be possible to cut threads into it, you could screw something on the end, like a toggle bolt or wing nut that you could get off easily. I don't know if you can die cut or whatever you call it when you cut the threads into the rod.
I think cutting threads into the rod will be even tougher because I don't have a lathe.
Right. And it's really hard steel. Just an idea. I'm not mechanical. You can probably tell.
No wonder I like working with wood so much, eh?
I was actually thinking a dowel would solve all your problems, but then when I found out you were using it for a shaft, maybe not so.
Well, when this is all done, it's, for the contest, I'm trying to keep below the 65-pound limit. But when it's all complete, it's going to be over 100 pounds. So, basically for, I don't know, either something having to do with gardening, lawn, or snow. So need a little bit of weight to get some traction.
But for which project is this, a Roborama robot?
It's going to be a Roborama. The less than 65-pound version will be a Roborama robot.
Cool, a Robo Columbus.
Robo Columbus, I mean, sorry.
Wow.
So
What about
it,
just changing over to a carbon fiber tube? Stiff and light and easy to drill.
I don't know if I've seen any 12 millimeter carbon tubes that can handle 100 pounds. But I'm all for it if it can.
I'm assuming they were magically strong enough. I don't know.
They'd
They're
probably be strong enough, but they're gonna flex in a funny way for a shaft.
Yeah, and carbon fiber is really brittle.
That's what I'd be worried about it when it does. If it has an impact load, that it splinters, and once it splinters a little bit, it loses all its strength.
Or it's going to wobble out the pinhole.
They're also not super round, right?
Okay.
They're the way they're manufactured, they're not like a bearing surface.
Interesting. Okay.
I don't know how well they'd work to try to put a sprocket on it as well to put a drive on it.
Cool.
We have used it that way, but it's
Caveats.
yeah, caveats. Yeah.
Easier to drill, more other caveats.
Well, lesson learned.
Give me a couple ideas. So I've got a cobalt drill bit coming in to try to drill it, and I was either going to look at a flat spot, but because I couldn't get it hot enough with a propane torch, but if I can get it hotter with a propane torch, it does answer my question. Thanks, guys. That it'll anneal it and it'll become easier to drill.
Let's hope.
So this is cool. Watching the wood guy do metal work.
Use a lot of oil.
Yeah, well, that's I've got a little drill press here, and I'm trying to do it. And I've tried a big bit, I've tried a small bit, and nothing seems to want to touch it. So I will see what I can do with other techniques. Thanks, guys.
Good luck. All right. Well, that takes us to our open mic phase of the night.
I have something.
Ted, excellent score. What you got?
So, I'm working on the Robo Magellan robot also. And last time I commuted, I had a flexible bumper that could squish in and press a button so I could tell if I ran into something. The problem with that was that the robot went around, the bumper would start oscillating and bouncing and press itself. So I wanted to build something a little more rigid. So I came up with this 3D printed piece, and you can see a bumper and a button in here, and it can press it. And I originally had the bumper in the middle, and that's what this nut was for, or bolt. But if you press on one side, only that side goes down more than the other. So I figured I could put a button on each side, and that way I could even tell which side it bumped into. And for this, funny thing was I got these hardened steel rods for it to slide on, and I tried cutting it with the hacksaw, and the hacksaw didn't do anything. So I had the same problems Pat had, and ended up getting out my Dremel with the cutoff wheel and doing that. But one thing I wanted to point out, that when I was trying to sand it down on the belt sander, it did get it hot enough to change the temper on it. So yeah, you could see it changing colors as it annealed and cooled off. So let's see, other lessons learned. I also had this idea to drill into the end of it to retain it, but I ended up putting this sliding catch on the bumper there, which was a lot easier than trying to drill into it. So sometimes it's my solution is to find a different approach, usually if something's too hard to drill into or that sort of thing. Let's see. Other lessons learned. Yeah, I put springs in there on the sides there. And right now it's a little hard, so I might have to look for a different spring so it presses down more easily. But anyways, yeah, 3D printing is great. I started out printing just different pieces, like this was to hold the button, and positioning them around, but I found you could get much better accuracy if you print it all like in one section instead of having like printing this section and this section. Although when you're trying to figure out the geometry of stuff, it's a lot quicker and you use a lot less plastic printing separate pieces. So that was my approach. Just print the small sections until I figured out how big I wanted things, where I wanted things, and that sort of thing. And then, yeah, then I printed it all in one piece. Well, two pieces really, the top and bottom here. And Ray, are you showing me something?
Oh no, I was trying to get something ready for a demo.
Oh, okay. Yeah, so yeah, and I just love the process of designing stuff in Onshape and then printing it out. It's a little bigger than I wanted, but I have plenty of room on the front of my robot, so it's not really an issue having something sticking out a ways, because I have plenty of room on the top to mount a bumper in the front there. So yeah, I think, and then this, I think I'll screw on like a longer piece of probably wood, because it's kind of the length I want won't fit on the 3D printer bed. So I'll take some plywood or something and screw that front bumper section on. Anyways, yeah, that's just wanted to show you guys my success here.
Way to go.
Looks
So,
interesting.
are you starting your Robo Magellan with the bumper, or build it around the bumper?
No, I have. I might have shown you my robot in the past.
Okay.
The base. Yeah, I can bring it out here. So it's this 6-wheel piece.
Oh, right. Yeah.
And so yeah, I've been printing some more 3D print stuff to kind of armor it up and close all the holes where dust and junk was getting in. So yeah, that's kind of it. And then the bumper will go on. Let's see, on the front here, something like that.
Uh-huh.
Yep.
Very nice.
And
All right, that's all I had.
Is that bumper a two-piece unit where like one piece slides backwards as it contacts the cone?
Yeah,
Yeah.
so
Cool, I like that.
there's the button in there. I need to put a spacer block in there. So because right now it doesn't actually touch, it doesn't slide that far. But yeah, I'll put a spacer in between so that button gets pressed. And then I'll have one on this side too, so it can tell if it's the left or right. Because if you can see, if you press just one side, just that side goes down.
Oh, I need something like that. Because my Robo Columbus simply is a lawnmower and it doesn't have a bumper. So that's like a major disadvantage.
Yeah. And so yeah, I haven't actually got it on the robot yet to test it. I just assembled this last night. So we'll find out if it works soon.
You should try and push it up against a traffic cone and see if it actuates or pushes the cone over in case your springs are too stiff or.
Right. And yeah, I have a feeling just by pressing it with my fingers that the springs are a little bit stiff now. So I might have to take a trip to Ace Hardware and find some wider springs.
So speaking of what, in response to what John said, I noticed that at the last Robo Columbus, there was a stake in the ground, and then the cone was sat over the top of the stake, so that it wasn't really all that easy to knock the cone off of the stake.
Interesting.
I don't know that that's a guaranteed setup.
Yeah.
Now you make it sound like a challenge.
says the guy with the 300-pound robot.
Yeah. I decided to go with a different approach for my front bumper. You can see right there, I have one of those time of flight LiDAR sensors. It's one of the really close range ones, the 6180, in my front bumper, which is just a little 3D printed piece. And the idea is, once I get within, I'm going to center using the camera on the cone and advance until I'm about 6 inches from the cone, and then basically just use odometry to go the last, because I get a very exact distance using that sensor if you're far enough away from it. When you get too close, I think the minimum distance about 2 centimeters, but if I'm about 6 centimeters away or so, then I can use the encoder on the wheels to drive forward, that amount plus maybe an extra 10 millimeters or something to basically guarantee that I'm touching the cone without having to actually have a touch sensor.
I like that. Yeah. Yeah. And that whole idea of
I like that too.
the sensor's not working when they're close range. That's kind of when I decided I needed an actual physical switch to do it. But I like your idea of using odometry. That makes a lot of sense.
Yeah, because it's really accurate when you're going slow in a straight line.
Right.
It's very accurate. So it's to move the robot forward 70 millimeters when you want, when you've measured the thing 60 millimeters.
Yeah.
Obviously I'm going to have to calibrate it with my cone, but that's the plan.
Yeah. Oh, and one thing about pushing the cone over, the one thing I notice is the lower you push on the cone, the harder it is to push over, obviously. But so trying to keep the bumper down low is helpful for that, at least for me.
Yeah, that's a really good point, actually. I don't know how low my bumper is. It is about 110 millimeters.
Okay, yeah, that's plenty low. That's so low that probably wouldn't make it much of a difference going lower.
Yeah.
I think I'm going to be about 200 millimeters.
Yeah, that's like 8 inches up. That's halfway up the cone almost.
Yeah.
Right. So you'll have a big monster, but it'll have more precision control so that it doesn't tip it.
How tall is that cone, John?
I think this point.
I don't know.
There are multiple sizes of traffic cones, so
This one is 17, roughly 17 or 18 inches tall.
I think I'm about 10 inches taller. I think I got a 27-inch cone here.
Yeah, so that's. I'm actually going to drive up on the base, but the bumper definitely hits the cone before anything else does. You can see that.
And John, you can keep it pretty well centered then with your this.
Well, that's the idea with the camera, right? I'm basically going to be running a model on the camera, you know, this is it's an OAK-D light, and you can run, you know, you run depth inference, and you can at the same time run a object recognition model. I'm going to try Cone Slayer, which is one of the models that Luxonis provides. And the nice thing about that is it gives you the coordinates of the object in camera space, you know, where it is, so you can find out whether or not the cone is centered. And because I'm getting that at 30 frames a second, you know, I can very exactly, as I'm driving in, servo in to keep that exactly in the middle of the camera space until it gets, you know, big enough that it's filling up the whole camera view. And then hopefully I'll be close enough that the depth sensor can take over from there.
Right, and so close that the steering won't make a difference at the last few.
Yeah, exactly. And the other thing is, of course, the depth sensor on the camera is only good down to about 20 or 25 centimeters. It basically stops working any closer than that. So, you know, I can get a sort of a measure of it till then, and by then it's close enough to the close range LiDAR, you know, the single beam time of flight sensor, that it can sort of take over for the depth sense. And then once I'm close enough with that, then I can just use it odometry. I was going to bring up, if anybody's interested, I've written a bunch of code. Well, I took an example from Luxonis and made some changes to it for using the OAK-D light. So if anybody's interested in actually getting a quick walkthrough of the code, I can do that. Does anybody want to see
Well,
it?
I'd be interested. Sure.
I have an OAK-D light. Yeah.
Yeah.
All right, let me share my screen. So it's just a little Python application. It uses OpenCV and NumPy and Depth AI. Depth AI is the library that Luxonis produces. Luxonis is the company that makes the OAK-D light. So I define a couple constants here, warning and critical, which is 1,000 and 500. Those aren't really that important. I have a couple image paths where I save files. In this case, I've got a 1 terabyte SSD hooked up to my Raspberry Pi 4. So I store I've mounted it off the home directory, so I store my files there. So the Depth AI, it runs off these basically pipelines that are made up of nodes. And the idea is you create a node for different things. So in this case, I create a node for the color camera, which is the camera in the middle. And then I also create nodes for the outside two cameras, the left and right ones. Those are actually monochrome cameras. And then you create a stereo node, stereo depth node, that connects to the left and right nodes. So you basically think about these nodes as things that have inputs and outputs. And so in this case, we're taking these two nodes, the output of these two nodes, and hooking them both to the input of the stereo depth node. And then we create this thing. It has this really neat thing called a spatial location calculator. And so we create that node, and I set up in this case, a 16 by 10 set of region of interests. And Mike has that funky LiDAR sensor that has the square regions of interests. So this basically does the same thing. The difference is that this is completely configurable. You can create the number of regions of interest that you want and the size that you want, and they don't have to be all the same. But right now I'm just making a grid of 160 little regions of interest, 16 by 10. You basically set the lower threshold and the upper threshold in terms of distance. This is like 200 millimeters and 10,000 millimeters, which is like, 20 centimeters and 10 meters. You create a rectangle that defines that region of interest and an algorithm. So it uses the median algorithm. So within that square or rectangular region of interest, it takes all of the depth pixels and it counts the median one, and that's the one that's the sort of the depth algorithm that it uses. And then you basically add that region of interest. So this creates all those regions of interest, and then we link the input depth. We link the stereo nodes output to the input of the spatial location calculator. And the other cool thing that we do is we create a sync node, and a sync node basically does time-stamped synchronization. So every frame that comes in from either the, each of these nodes that is output are time-stamped based on, wall clock time kind of thing. So you want to make sure that the RGB image that you grab and the corresponding depth image that you get are from the same instance in time. And so you create a sync node and set its threshold to be 50 milliseconds. And then you basically link the input, one called SLC, and that links from the spatial location calculator, and one called color, which is linked to the CAM RGB node. And then you create an output and link it to the sync's output. And so all of this is all just set up that you're running in Python here in the library. But when you say this line here with device pipeline as device, what that ends up doing is that copies that whole pipeline definition into the camera itself. So now the pipeline is actually running in the camera. It's not running on the Raspberry Pi at all. And so we create a queue that grabs data from this output group and basically just sit in a loop now. This while true loop just runs. And basically I grab an entry from the queue, which is a grouped entry, and it breaks it up into these things that have a name and a message. And in this case, the name is the name of where it came from. So in this case, if it's color, then that means it's a frame from the RGB camera. So we're going to call get CV frame, which will give us an open CV image object that is the color camera's frame. And if it's SLC, then we get spatial locations from it. And so we basically run through those, grab both of those things. We get a color frame and we get SLC data. And then we basically, what I do, I create a text line because I'm going to output a bunch of data to a text file as well. But then we walk through the spatial location, the region of interests. And for each one, we figure out what its coordinates are, x min, y min, x max, y max. And then we grab the distance from the spatial coordinates of the depth data, which is using basically a 3D version of Pythagorean. And then if the distance is less than the critical one, then we set color to red. And if the distance is less than warning, we set color to orange. Otherwise, I don't bother doing anything to it. Although this is obviously going to change when I'm running it on the robot, actually autonomously, because I want all of the depth data and not just the stuff that's close. But in any case, and I basically append a bunch of information to my line about that region of interest, basically the distance and then the XY coordinates of the rectangle. I use OpenCV to draw a rectangle in the appropriate color on the color frame in the right place to represent that. And then I output a piece of text to that image as well, which is basically the distance in meters, to the depth in meters to whatever it's seeing. And so then I just create an image file name with basically frame dash and a 8-digit number .jpeg, and I use OpenCV IMWrite to write that image frame out to my SSD. And then I also output a line to my text file. And then it's just calculate so that I'm running at 10 hertz in this case. If I'm not grabbing the image from the color thing, which of course transfers a lot of data between the camera and the Raspberry Pi, then I can run this much, much faster than at 10 hertz. But with that, I can only run it at about 10 hertz. And so this basically sits in a tight loop, and every 10th of a second grabs a frame, annotates it with all the region of interest and the color, and it overlays it on top of it. And I think I showed you guys some of the images last week that it produces and does that. And that's it. That's the whole thing. And the idea is, of course, the region of interest stuff is the really interesting stuff that you get back from the camera. And so you can look at each region of interest, you can group them together how you like, and say, you know, maybe I don't care about the bottom 4 rows because that's too close to the ground. You know, it just sees the ground at that level. So I'm going to look at the top 3/4 of the image, and I'm looking for, you know, obstacles that are up there like bushes or trees or you know, the corners of houses or whatever. And so when you get enough of a bunch of regions of interest at a particular range, then it's like, okay, that's an obstacle. So now let's go around it.
Are you looking at the colors at that point just to see if it's
well? This is the color is just so that we can tell. We looking at these images can tell that the obviously the autonomous algorithm doesn't care about that. It just cares about distance. So it's it's really just about you know, in the robot, I'm not really going to care about the color image at all. I'm not going to be pulling it across when I'm running in actual autonomous mode. This is all just set up to do testing and to try and figure out what kind of data I get from the camera. But once I'm running in the real, you know, autonomous controller, I'm not going to be grabbing that color image at all because I don't care about it. All I care about is the region of interest data from the cameras, from the depth cameras. Of course, the color camera will also, in addition to that, be doing object detection. And of course, the objects it'll be trained on is orange traffic cones. So when it sees an orange traffic cone, it's going to send back metadata about that. But and that's the awesome thing about the OAK-D is all of that stuff happens on the camera, and you just get back a very small amount of metadata. So in this case, you know, I'm getting back, instead of getting back a, you know, whatever, I think these are like 2K images. So instead of getting, you know, 2 million pixels back from the camera every frame, I'm getting 160 pixels worth of data from region of interest. And you know, the pixels are not really pixels. They're really information about the data and the width and height of the rectangle and stuff like that. But it's really a lot less data to capture from the camera than trying to run, you know, like for instance, Bob Cook, you know, he gave a presentation here a while back, and you know, he was trying to do inferencing on the Raspberry Pi. So of course he's got to send the frame from the camera to the Raspberry Pi and then run the inferencing engine on the Raspberry Pi. So he's getting like 1 frame every 1.5 seconds or something. So with this camera, you can do inferencing at 30 frames a second.
So the object detection would be in addition to this code. So this file will grow bigger, right?
Yeah, well, the object detection is you know, is going to return basically a collection of objects. So it'll be a label and, you know, the rectangle and the depth. because of
Yeah.
course it's also spatial.
But I was asking, so you have this one Python file, but you'll add all the object detection
Oh, yeah.
setup and stuff in the loop, so it just gets bigger. Yeah.
Yeah, the Python code is going to get bigger, but I mean,
Right.
I'm not going to be doing the RGB camera stuff. I'm going to be doing object detection stuff instead.
Oh, I thought it'd be both.
Well, when I'm doing my initial testing and calibration and stuff, I'll be bringing the image across. But when the robot is running, like in a competition, or
Right.
once I get all that stuff done, I'm not going to be bringing the camera data back because I don't need it.
Right.
What I'll do is when I see an object for the first time, I'll grab a frame from the camera and save it to the hard drive so that I can go and look afterwards and say, yeah, okay, there was the cone that it saw, kind of thing. But I'm not going to be saving, every frame from the camera. That's silly.
Yeah. But this Python file would set up the object detection
Pipeline
in the camera, and also set up the this depth detection.
Yeah, that's
and
right.
Then the camera would send back just relatively simple data.
Yeah.
Okay. Mm-hmm.
Yeah, and that's the idea. You don't need a powerful machine. Like a Raspberry Pi 4 is kind of overkill for this. I could use a Raspberry Pi 0 easily and still do inferencing at 30 frames a second because it's just not sending much data. But since I've got a Raspberry Pi 4 and it's already there, what the heck?
Mm-hmm.
So yeah, that's I was really impressed by how simple it is. Like the example that they gave us didn't include the sync node at all. And of course I found out when I started running it that the color image and the depth image were completely out of sync. And so I did some looking and figured out, okay, I need to add a sync node, and they had a couple of examples of how to sync various things. So I sort of incorporated that into this code, but it's really straightforward stuff. You really create nodes of particular types and you configure them and you set up the inputs and outputs, and then it just works.
So does the sync node somehow just serve as guidance to the camera to grab at the same time, or does it somehow?
No. What it's going to do is, you're basically looking at streams of data, right? So
Okay.
You've got data coming from the depth, not so much the depth camera, but the algorithm that does the spatial depth information. You're getting frames from that. And you're getting frames from the camera, and each of those has a timestamp associated with it. And so what it does is it basically, if timestamp A is here in this one and it's here in that one, it's basically going to dump frames for this one until they get to there, and then they'll start moving together and grabbing frames at the same time that are linked together. So it may end up making everything a little bit out of sequence from real time, but at least the camera view and the depth view are synchronized at that point.
Okay. And then it sounds like you can choose which points to synchronize, whether it's the raw spatial camera feed or the processed camera feed, because there might be some latency in there, right?
Yeah. You basically hook up. So in this case, I'm syncing the raw color, the RGB node, with the spatial location calculator's output data.
Okay.
So, in the future, when I start doing object detection, I'm going to sync the object detection's output with the spatial location calculator's output, because that's really important to have them synchronized, because the data that you get back is not just the XY coordinate of the cone, it's the depth of the cone as well.
Right.
Because it's a 3D image. So it does object recognition, but it also gives you depth information, and it's not based on sizes or things like that. It's based on the stereo cameras. So
did you happen to measure the like how much of a lag was in this two streams before you synced them?
I think it was somewhere around like half a second or something like that.
Wow, that much.
It
Wow.
might have been less than that. I don't remember. I'd have to look at it again. Like I'd have to
But big.
take it out and run it again. But
I think
you know,
brought up a really important point when you said that they could start at different times, and yeah, I hadn't really considered that. I thought, but if you just pulling frames one off the one stream and one off the other stream, then if they started half a second apart, they'll continue to be half a second apart. If you pull a frame off of each, one after the other.
well,
And the sync node takes care of that.
yeah, I mean the stereo cameras are synced automatically. The two cameras that do the stereo depth inferencing, those are already synced. But I suspect what's happening, the discontinuity here is that the spatial depth calculator takes time to run. So that introduces a latency to the output of the stereo depth calculator, the amount of time that it takes to process the two frames from the stereo cameras to produce an output. So that amount of time that it takes to process that. Now, I don't think, it certainly doesn't take half a second to process a frame, because you're getting 30 frames a second or whatever. You're getting a lot of frames per second from the depth calculator. So it may just be an initial setup thing, or I'm not sure what it is, but it's definitely the case that you want them synchronized.
Yeah. Well, I noticed on the example I had at Moonday,
This is really good information.
with the human pose, it was like half a second or a second behind people's movement on the camera.
Yeah, that one doesn't surprise me as much, because it's a much more complex model that it's running to do that.
Mm-hmm.
So,
but that's the kind of delay we're talking about. Yeah.
Yeah.
Right.
Yeah, and that may be a limitation of the OAK-D Light's camera as well, or its system. It's really advanced stuff, but I mean, it's also the low end of their stereo cameras. So it may be that their OAK-D Pro thing, does it a lot faster or whatever. I don't know, because I don't have one to play with.
Mm-hmm.
So,
do you know if the? I have a couple cameras and I haven't had a chance to play with them much. Do you know if the libraries are there built-in mechanisms that tell you what the lag is through the computation algorithms, like from the real-time sample to the computation output?
For the OAK-D, you mean?
Yeah.
I don't know. I don't know if they have that. I haven't spent a lot of time looking, like just studying the API. I just took their example that seemed to do close to what I wanted to do and modified it to make it do what I wanted it to do.
Cool. Nice. All right. Well, I think in the open mic queue, I think Ray, you had something you're going to go in, and then more open mic after that.
Yeah.
I got something stupid to share.
And Kareem, excellent.
Okay.
I live for stupid things.
Okay. Disconnected. Connect. Okay. Come on. Now it's not going to connect. There we go. And let's see if I can get this to run.
Can you guys hear me?
On and off, you're choppy, Paul.
Okay,
More choppy than audio.
okay, there we go. Okay. It's actually gonna work.
Okay, I'll try getting to the phone signal.
Oh, that's right, it's red.
All right.
Thanks. I'll speak up.
Okay.
Okay. Well, we finally got this working. Hold on a sec. So, Paul, you gonna go or you want me to go?
I think
you're
Paul
going,
says
Ray.
Paul's got he's gonna he might try and dial in from a phone or something. So Ray, I think you're up.
Okay. Okay, can you see that image?
Yeah.
Moving around. Okay. This is the Max Cam from Cypede. And it's kind of a nice little unit. It's got touch screen on the back with a, over an LCD. And right now, let's see, it's pretty subtle. If I shift this, you can kind of see the box around it.
The outline, yeah.
Yeah. So it's just doing blob detection on red, and it happens to be close enough to this red that, yeah, there you can kind of see it. And it's picking up one off that piece there, a piece of foam. Anyway, so the reason why I got this was supposedly you can do, basically detection models where you train it. So, you give it all the photos and labels and all that kind of stuff. And supposedly you can create your own models with it. I think it's using YOLO version 8 to do that. But I just got the thing and just started playing around with it. And I think I need to reload some things because not all the files for models are showing up where they're supposed to be, but I think I just figured it out a few minutes ago. Anyway, so it's kind of a neat product. These are all the examples that you have. It's just the same ones in OpenMV for the OpenMV H7 or H7 Plus. I think right now I am using, and there's actually two fine blobs. This one has very little data that's written on it, and the other one has so much data you can barely see what's going on with it. And I think it's actually, yeah. So let's see, code, perimeter, roundness, elongation, area, density, extent, compactness, solidity, convexity. It's just way too much stuff to stick on a screen. So and for every, I think, yeah. So you can kind of see all the data that it's actually trying to print on the screen along with,
That's really cool that you have all that information available. I mean, it's pointless to print it on a screen when you're running it on a robot.
Right.
But it's really cool that that information is available via the API.
Yep. I don't know if you can see all those.
Oh yeah.
All the parameters there, but yeah, it gets to be so much that you can't see what's going on the screen. Anyway, so I thought it was kind of neat. It's oh god, I want to say I think it was $48, which right now, the more expensive OpenMV, it's the one that's based on the Sony sensor. It's the one that Mike Williamson bought.
So you're telling me for $48 that can be a Terminator?
Yeah, if you want. Anyway, so for what it does and for what it costs, it's really, I don't know, it's a pretty good value. This one connects through Wi-Fi, which is kind of nice because you could have this on a robot, and the IDE on your laptop, and be looking at what the robot is seeing as it's seeing it. So that's kind of nice. If you wanted to do that with like the OpenMV products, you actually have to add a little Wi-Fi module to it.
So you're saying it's better than the OpenMV?
For the price, it's
What processor does it have? Is it slower or faster than the OpenMV
I think it's faster. It's actually an SoIC with like multiple processors in it.
So is your Python code that you have there, is that running on the camera, or is that running on the machine that you're connecting to the camera?
Yeah, that's actually running on the device. There's a little, you can have it run on Max Vision, which is on the, on your laptop or wherever that IDE resides, or you can do it on the device. So I was hoping to get to the image basics, vision.
It'll be AI vision if you're looking for.
Yeah, there it is. Yeah. So here's like this face detection,
Try the YOLO V8 pose.
Yeah, I don't think these are going to work because I don't have all the model files in the right place.
Okay, yeah.
But we can see what happens. It's probably going to bomb right here on root models, YOLO 8 pose, because it's not where it's supposed to be at this point. But I did find out how to get it there. So, yeah.
How do you spell the name? I can't find anything on the Max Cam.
MAIX.
Yeah, MAIXCAM.
Oh.
Yep. There's several, companies on AliExpress that sell it, and I think you can go to the SciP website and buy it there still. But as far as, okay, I'm gonna get out of this. Don't save. Don't save. Don't save. I think, let's see here, there's.
Wow, that's got some serious hardware in it.
Yeah, I think I've got way too many tabs open here. I think it might be here. System. Anyway, yeah, so the touch screen, it's, you kind of like these circle around, and, they've got an app for AI detector and that kind of stuff. Let's see here if it says what's in it.
Is the touchscreen built in, Ray? So
yeah,
it's not like you have to buy a separate one like you do for OpenMV.
It's on the back side.
It's just right there.
Yeah. And let's see, I don't know if I can get it to do anything. Yeah, so you can kind of scroll through. There's AI classifier, find blobs is an app that's on there. AI detector was the one that I wanted to get going, but haven't done it yet.
Yeah, I mean, looking at the specs, that almost looks like a Raspberry Pi 02 running on the camera. I mean, it's got a gigahertz processor running Linux.
Yep. Yep.
That's scaled way up from what OpenMV uses.
Yeah. Yeah, I'm not finding the website that says all those things, but
it's on their wiki.
Yeah.
Did you get it from AliExpress, Ray? Or
yeah, that's where I got it from, AliExpress. Let me look up the exact price. I want to say it was $48, but it may have been more with shipping.
It's $50 on Amazon.
Really?
Amazon has it? I'm going there right now.
Yeah.
It's actually pretty impressive. I mean, the NPU, which is the neural processor, does 1 TOPS, which is 1 trillion operations per second. As a counterpart, the OAK-D Lite has a 4 TOPS processor, but it's doing stereo depth at the same time as it's doing the other stuff. So this has roughly about the same amount of power to run models as the OAK-D Lite does.
Yep.
That's pretty impressive.
Anyway,
for
this
that
was
price.
like 50.29.
I think I just saw it for 32 on AliExpress.
Yeah, this one actually had, included an SD card with pretty much all the stuff on it that you needed. And I thought, okay, well, I'm going to have to buy an SD card anyway, so might as well have them put whatever on it that, I need to put on it. And so I think there's a couple different bundles that, so 46 with the card, it was $50. You can buy just, the camera unit itself, doesn't include the touch screen or the LCD in the back or the little 3D printed case.
It might have been 32 without the screen.
Yeah. So anyway,
Ray, you might need to request a spiff for referral sales. I'm sensing there's going to be several purchases after this session ends, if they haven't happened already.
Yeah, just about.
Don't have it on Prime, but it takes deliveries between August 7 and 19. It's like $17 for delivery, so it's unfortunately not in the U.S. warehouse. It seems.
Yeah.
Oh yeah. Well, I think I got free shipping on that one. But so there was actually a version between the Max, I think this was the Max 1. There's a 2, I think a 3, and now this is the Max Cam, and that seems to be, the most powerful of them and the most capable. So that was the other thing that I liked. I have, I've got a bunch of these M12 lenses on, other cameras and stuff. And if you want, to interchange a lens, it's, that's pretty easy way to do it, is to have them all be the same M12. So, but anyway, so the other thing that I got, I still haven't given up on the Omni lens. I'll be back in a sec.
While we're waiting, I'll just do an addendum on the OAK-D Lite. One of the things that you have to be careful of, obviously, is power usage, because the Raspberry Pi, especially a Pi 4, has a limited amount of power available on its USB ports. So I've got a powered USB hub that I'm powering directly from my 5-volt regulator that I'm running the OAK-D and my SSD off of. So if you guys end up playing around with OAK-Ds, you want to make sure that you get either use some kind of Y adapter to power it or plug it into a powered hub.
Anyway, I was looking for different
John, I was using an Oak Light with a Raspberry Pi 4, and I was, it was essentially plugged into the Raspberry Pi 4, and I was using I want to say it was a 3-amp supply, and it was handling it without any issues.
Yeah, they say in the docs that works some of the time, and depending on which models you're running and stuff, you can end up using more because the Pi can only produce 900 milliamps.
Yeah. Yeah. I do have a Y, but I didn't need it. You know what I mean?
Yeah.
Anyway, I was looking for different reflector lenses.
Doug, can you mute yourself? Cool.
Anyway, I was looking for different reflector lenses for kind of what I'm calling the Omni camera. These are hemispherical. It's actually polished steel, and they're you can get them in different sizes. They're like a couple bucks each, but in place of the lamp reflector or the flashlight reflector, I was going to try to incorporate these in so that the camera would be focused on the center of that and give a 360-degree view of the surroundings. So I've got different sizes to experiment with.
You should get much better results with that because it's a dome instead of a parabola.
Yeah. And these are really cheap. I mean, like I said, a couple bucks each. Here's the really big one. And that one's like closer to the diameter of the one on the flashlight or lantern, I guess it's what it really is. So they're not perfect. They have a little bit of wave in them, but good enough for the image is pretty distorted anyway. So
Ray, are they coated on the outside? I mean, you said
it doesn't
steel.
say they are, but it's like a mirror finish on it. So I don't know if it's chrome coated, maybe. But it's like a highly polished.
Yeah, I was going to say I just came across some diamond 20,000 grit diamond paste, which you can put on just a dab on a piece of cloth, and it's incredible what it can do. So I mean, if it's just a steel surface,
yeah,
you could maybe even push it up a little bit, but it looked good enough to me.
Yeah, they're actually like for caps of like for posts and stuff. So, and the inside is dull. It's not polished.
Yeah. Can you put the link? Can you put the link in the chat? Because that is really interesting.
But oops, lost all my wrapping. Yeah, I got those from Amazon too.
Wow.
Where were they? Yeah. And you can get them in all, different sizes. And, I think the smallest one's 53 cents versus whoa. If you want one that's 600 millimeters in diameter, it's almost $300. But, I guess you can't see my screen. Oop.
You could probably use a Christmas tree decoration. It doesn't matter that it's completely spherical.
Yeah. So the cheapest one is 53 cents, and the most expensive one is $300 or close to it. So, but yeah, I think they're okay. Stainless steel. It doesn't say it's got chrome on it, but it's either very polished stainless or just meant really for decoration. It's a millimeter thick 304 stainless steel pipe head. So, do you want any? Well, I could suppose I could do that.
Just put the whole link in. Up to the HTML question mark. There you go.
Yeah. Chat there. The other thing, talking about going down rabbit holes, I had one of the ESP32 based three-phase motor drivers, and you know how the Arduino IDE will come up and say, oh, you can upgrade some or update either some libraries or some boards. Anyway, apparently Expressive put out an update for their processors, for their boards. And I didn't realize it, but I was actually on a version that happened to work with the simple FOC libraries. And the latest version does not work with simple FOC. I think it's like version 3.03, and I was like on version 2.17. And, I thought I was doing something wrong with the code. I tried all kinds of things. It was like, oh God. So I just finally looked around on the simple FOC forum, and the exact errors that I was getting, someone else already put in there, and they said, oh, don't use the latest version. It's FOC hasn't caught up with it yet, or simple FOC, and go back to 2.17 or something. And that's what worked. So I guess it really, maybe, if you run into that again, where you do an upgrade on, on boards and on libraries, and something like that happens, just go to the forum and take a look. So, like I said, it threw me for a loop. So anyway, so that's all I had.
My next.
Yep, I think so.
So real quick, the going back to Moon Day, one of the things that Iron Rain was up to is they created a mini hovercraft, and we're playing around with that. So this is plastic fastener sumo on top of a hovercraft.
Yes. So BB-8 wasn't involved under there somewhere or something, a little miniature one or something, balancing it on his head or something.
No.
It kind of destroyed the Lego bots.
Oh no. Ooh, these parts are coming off.
Kind of a free fall for him.
Yeah, they got a little destructive there.
I bet that was well received.
Yeah, they were having fun. They were actually. This is human Pong.
So was this an original design, or did you copy this from somewhere?
So that was it. That's all I was going to share.
That's pretty cool. So was that an original Kareem design, or did you copy that from somewhere?
There's tons of these. This is just a leaf blower hovercraft. It's a
Wow.
battery powered one. It's like 80 volts. So it's the Harbor Freight Atlas. So
Huh.
it's got plenty of power for somebody slight like her. But we were like giving kids rides around the museum all day long with that. But then we decided to throw it in the arena and try human pong. We couldn't get it going fast enough to like bank off the walls, though.
What'd you use for bumpers on that thing?
So this is just pipe insulation.
Spread open.
Huh? Yeah, it's just open, slit open from the side, like you would put on regular hot water pipes or whatever. And we just it's like a 1/2-inch plywood deck, and we just covered it so that it wouldn't be quite so dangerous when you bump into it. And then it's got an air cushion underneath, of course. So, but it's the foam that really serves as the bumper.
So what's the skirt made out of that?
It's just trash bag.
A trash bag, really?
Trash bag, yeah. Well, pretty sturdy trash bag material.
Yeah.
But it doesn't take much. We did the calculation on it, and it was something like if you calculate the weight that it has to support, you can figure out the differential PSI over ambient, and it was like 0.1 something PSI. It's a tiny amount of extra pressure that you need. So that means that the stresses on the plastic aren't that high. It's all averaged out over the whole thing. I mean, it was actually a little bit higher because it's got a bag skirt on it. Finger skirts are way too complicated for something like this. So it's basically, it looks kind of like if you throw it upside down, it's kind of like an inner tube that's got a bunch of holes in it. So there is a slightly higher pressure on the perimeter in order to keep the skirt inflated. But it's still not that much.
I'll be darned.
Okay, I'm envisioning something here. We get the Kareem Iron Ring kids together with the Carl Ott Asteroid Mode bot. That's what I'm thinking right now.
All you need is a big old fan.
Yeah.
Fan to move it around then.
Yeah, that's next. They haven't done propulsion yet, but yeah.
Oh, there you go. Another leaf blower for to move it around. That'd be great.
I guess leaf blowers are more infinite supply than fire extinguishers.
Yeah. Fire extinguishers, they're pretty expensive to top off again.
Pretty expensive, but they have a much more of a
energetic push. Yeah.
Yeah, and the kind of
they're fun.
Heads, yeah. And they put out the fire as they move you away from it.
Don't think they would have been happy with us using a CO2
a
fire extinguisher inside the museum.
Maybe not, but I'm glad they let you get away with that. That was cool.
Yeah, nobody bothered us about it. It was a little bit annoying. It was loud.
Leaf blowers.
So we're trying to. I was trying to have them do it as seldom as possible, but there were lots of kids who wanted rides on it, so it was much slower. We weren't putting little kids on in the arena with robots running around pushing them. That it was just gently pulling them along. But yeah, it was a popular ride.
Yeah, I guess I don't know if you've ever seen the videos of the Devil's Wheel in like Munich during Oktoberfest. It's kind of like a smooth dome, and the whole thing spins around. And they have, basically women get on the thing and try to stay on it. There's no. Basically, it's just whatever friction you can get with your shoes or your hands or whatever to stay stuck on the thing. And that'd be slinging kids off in all directions. That'd be a good one.
Very cool. Well, thanks, Kareem.
Sure.
I will tell you that Moon Day was a lot of fun. And for those of you who were there, I think everybody had a great time. I'm sorry I'm a little late here if everybody's talked about it already. I still like it. I know I had a really good time and really enjoyed my time there. It was cool.
Did you guys get to go around and see the other exhibits or just booth duty?
I walked around. I saw a couple of things. There was a couple of folks that said they were going to come see us. I don't know if they ever did, but some guy had a real BB-8 that he built in there, and there was the astronomy guys were right across the street from us, and those guys were cool to talk to. We probably annoyed them more than anything with our with my basic computer with sounds going on it, and a combination of our robots running around everybody between us and them, between the R2 units and the other robots they had going on. We stopped up traffic there a few times. Maybe we got them to promote some of their astronomy stuff. I don't know, but it was good. I'll do it again. It was a good time. It's a good time. And I must commend the Iron Rain folks. I did not see Mickey Dean. I did not see it rotate and move. It looked like it could, though. It looked like it has from like just straight marks when I looked at it pretty close. I wasn't going to interrogate the person.
It does work. Yes. It balances and drives around.
Yeah, it was really stable where it was. And so again, it was a good time. I got to hang out with some folks. I got a couple of wacky pictures that I put up on Facebook. Hey, I got to go to the moon, I felt 1/6 what I normally feel, so I don't know what's going on. And no, it was. I thought I was going to go to some of the talks and stuff that was there because I thought they might have been interested. But by the time I got there, and time I got going, I looked around. The talks were like in the process, and I'm like, I missed them. I missed them. Oh, I missed that one. The Mars people were right next to us. As cool as they weren't as cool as we were, because their Mars rover was a rock crawler that they threw a cardboard box on it and put some lights on it. So that was their Mars rover. I suggested maybe my rover could take a tour on that thing, and the guy looked at me sideways, sort of thing, and I guess I should have done that.
Didn't like that suggestion, huh?
No, he didn't quite like that. So,
well, they let me run my ball on it, my little baby ball.
Yeah, your spheroid. Yeah, your spheroid is not a 6-wheeled gargantuan thing, or comparatively so. Anyways, my rover's not that big, but compared to your little ball, it's a lot. Your little ball was cool, by the way. It got lots of good attention as well.
Yeah, did you get the styrofoam parts for that at like Michael's or something?
Oh, I just had
Mike?
the little baby one inside.
No, but the styrofoam ball, I saw those at Michael's the other day. Is that where you got yours or no?
I got it on Amazon, but I need to go find the one at Michael's, see if it's any cheaper. Yeah.
Oh yeah. Yeah, it looks identical to what you had. So
yes,
as far as I
need a 10-inch. But yeah,
they may have one. They had a lot of different sizes. So
Can you guys hear me?
Yeah,
just barely.
Is this any better?
Oh yeah, that's good.
Okay, I dialed in. My phone seems to be doing better than the Google Meet. So while Doug is on the line, I wonder if we could circle back to the discussion we had earlier about bumpers and non-bumpers on the for Robo Columbus. And so this is kind of a Doug rules question. And so, Doug, are you online listening at the moment?
Yes.
Okay. So I'm just pasting a link to the rules into the chat, and and I was recounting to the group that last Robo Columbus there was a stake inside the underneath the cone so that it didn't move when the robot. In fact, my robot tried to climb on top of it, and it still didn't move. and
We had no
Kareem
stake.
said,
There was no stake into this. There's no stake under the.
I think, Doug, that there were. I think that we did when we first laid it out, put a couple of tent stakes in the ground, and then somehow they stayed there when the cones got on top of them. At least for one cone. So there was a discussion of that earlier on.
Okay, I had to step away. Well, the intent is not to have a stake there, because the last couple of years, what we've done is we've actually used paint to mark out the 10-yard circle. And so, or 10 foot, I can't remember, it's either 10 feet or 10 yards, whatever the rules say. And it's easy to just where the cone's supposed to be. So if somebody moves it, you can just put it back. So I don't know if there were stakes.
I see. So it's not even assured that in any way that there would be a stake that would prevent it from moving. So a robot that needs to have a kind of a gentle touch to it to not move it and not incur the 2-minute or the 8-minute penalty for moving the cone.
Right. If there were stakes, they were supposed to be. Okay.
Yeah. Don't want to invoke the wrath of Doug.
Well, I'm just saying there shouldn't have been any stakes there. But so like if you crawled up on it and started humping it, that'd probably get you a penalty.
Whoa, hey.
Well, the rules specifically say, say that the penalty is only invoked if the base of the cone is physically moved.
Right, because you can rock the cone.
Yeah.
Okay, you can hit it, and because if you really took that to the nth degree, I don't care how gentle you were. Well, I'm sure you could be gentle enough not to move it at all, but most people move it a little bit. Maybe not enough that you would say they moved it, but if somebody was really being picky and trying to say, well, he moved it, and so he should have got in, so we said the base. And so if you hit it at the, so if you tip it, that's going to move the base. And if you hit it at the bottom, you can hit it pretty hard without moving it. But it definitely it helps to have a bumper that's pretty sensitive, and that's kind of one of the things that you have to trade out. Do you have a sensitive bumper, or will you get false trips, or if you have one that's not sensitive, will you just ram the cone in? Because the cones don't weigh that much.
With mine, my tires are sitting on the base of the cone, when the thing hits, and
Yeah.
I can hit it really indent the cone without moving the base at all, kind of thing.
Yeah.
Because the tires are holding down the cone.
Well,
I mean, it might slide the cone.
Yeah.
A little bit.
I think realistically, we're doing this for fun, guys. You know,
Yeah.
what we're actually trying to do is what we would, if you go to Robo Magellan and you hit the cone and it moves, I think they're more strict about it. Okay. So our intent was, because I mean, to be quite honest, if you get 9 points, even if you get a penalty on it, you're still probably better off than a lot of people. Do you know what I'm saying? And so, but and John, if you touch the base, if you didn't even touch the cone part, but if you touch the base, that's considered touching.
Yeah. Yeah, I saw that. So it's
Any part of the cone.
Yep.
Yeah.
Cool. Thanks for answering my question, Doug.
So, Paul, probably don't want to hit it super hard. I guess that's what I'm saying.
Thank you.
Yeah.
So if I had curls, duct tape and baling wire, and I Dukes of Hazzard the cone, but it really didn't move, that's okay. I'm just trying to get clarification here.
Yeah.
Because that was fast, man. That little car was fast from a couple years ago.
Yeah.
It was fast.
If only it didn't. Yeah.
I think the rule should be if you hit the cone and move it, as long as it's back where it started, when you back up, everything should be okay.
Yeah. Well, I think
if you climb halfway up on it and tilt it over and then back up and it goes back down again.
Now I'm thinking if you just have to touch it, I put a bunch of whiskers around my robot and have it just drive past and one of them touches it, right?
But you got to stop, because if you drive by it, you get the point for touching the cone, but you don't get the point for stopping.
So does this mean on Ted's bumper it's going to get whiskers then? He's going to get little cat whiskers on his bumper.
Yeah.
I'm waiting for the one that's like one of Kareem's robots where the arm is up here and it gets close and it just touches it, comes up.
It's just part of the goal. Yeah.
10 yards away.
Actually, I thought about putting cat whiskers on mine, too, or whatever, cockroach antenna, because when you get near the Texas thicket, that's kind of hard to sense. But if you have a foot long, like piano wire or something really, well, probably not piano wire, but something, they make like, I don't know, 3/32 steel rods that are about 4 feet long that I probably wouldn't use one that long, but that I think would make a great Texas thicket detector if you catch the end of it and it trips a switch and gives you enough time to turn away from it.
If it catches on the stuff and then you back up, it's just going to bend completely, and then it'll start touching the ground as you're driving and boom.
Yeah, and they start bouncing.
Carbon fiber rod that you put into
there you go.
Yeah.
Build a 100-pound robot and run everything over.
Right. That's one way. Carry a waterfall.
So if you flatten the cone out, but it doesn't move, you just squash it down flat.
Yeah.
That's still 4 points.
It could be the Pinata Mobile bot, because then like you could get close to the cone and cover up the camera and then just swing around wildly.
There you go.
See
Start
if candy
flailing.
flies out of the cone.
I did notice one thing with whiskers, is how usually how they use those is they have like 2 pins and your whiskers in between them.
Mm-hmm.
And so when you get disturbed, you touch one side or the other.
Mm-hmm.
All right. Well, you need to make sure that these two pins are a lot wider than you think they are, because you really want the whisker to be moved quite a bit before you trip it. You don't
Mhm.
want it. You don't want it just bouncing between them while you're bouncing over the grass. You know what I mean?
Yep.
Yeah, that's the problem I found last time I tried something like that is as soon as your robot turns or bounces, they start going and you're done.
Yeah. Okay.
Someone's
that-
dog
that's-
agrees.
That's kind of the reason why I'm going with the whole virtual sensor thing, where it's not dependent on touch at all. So it's much harder for it to get, I mean, it's not going to be bothered at all by bouncing around in the grass and stuff like that, because I'm not even going to pay attention to it until I'm within like 8 inches of the cone and
Mhm.
starting to crawl forward, kind of thing.
Mhm. Well, I guess you're trading off the ability of a last like Ray robot 2 years ago. He had got himself into several situations that he was using when his bumper would trip, he would back up, and so he was using that as like a final obstacle avoidance trigger.
Yeah.
So there is some advantage to that. And it doesn't really hurt your performance too much if you accidentally trip it way out somewhere. It just backs your robot up and then it retries. The big problem is if it just gets stuck in a tripped position, then you've got a problem.
Yep.
So
Works good
Hey,
for
Doug,
horse.
can we get extra points if we pick up the cone and take it with us?
maybe next year. That sounds like an idea challenge. But right now, nobody has had a robust enough obstacle avoidance to do the 3-cone challenge, the 3 waypoint challenge.
Really?
No.
Wow.
Because
right?
and part of that is because where we placed the cones last year. I mean, Scott had pretty robust obstacle avoidance, but there was to do that, you're basically going to do some sort of obstacle wall falling, because and we had a section where it was like barbed wire fence over about a 10-foot drop, and he didn't want to. He decided he didn't think he could reliably sense that, so he went ahead and put a waypoint in there. So that gets you 10 points if you do that, I believe. If I remember the rules, you get 10. That's the only way you can get 10 points. It's the 3 waypoint challenge.
I'm just happy getting more than 1 point, really.
Yeah, I know what you mean. Yeah, because if you get 3, that means you've done the core of the problem. Now you just have to figure out how to get to the next cone.
I don't see anything in the rules.
If you can get within a circle, that's a good start. Some of us have never made it to within the circle.
Yeah. That is that. That's the whole idea of the thing. If you get 1 point, you get a cup. You're a winner. You get one of the mugs for that year. And I'm still working on the design, so we should have that here in the next couple of weeks, hopefully. I'm having to bug my artist.
So, Doug, do you get a mug? Do you have to place in the top 3 to get the mug?
No. Okay, the way the mug works, there's cash prizes like we had for Roborama.
Right.
Okay. So first, second, and third. But there's also anybody who gets a single point gets a mug. Now, if you get 9 points, you get a mug that says perfect score, 9 points. And if you get three-way challenge, or whatever it is, the three-way point challenge, you get one that says perfect score, three-way challenge. So there is some differentiation between the mugs if you really ace it.
Yeah.
But, you know, last year, nobody aced it. We had somebody, you know, Scott got 8. And
Scott got close.
What's really funny is when we did this at another location, and it was just as hard. Okay, so I'm not talking about, in fact, it might have been harder. And Scott and David both got 9 points on that. So we had 3 competitors. I was competing that year, and they got 9, and I got, I think it was 4 or 5 or something like that. So, you know, it was, but it was kind of interesting how the location seemed. This has been a harder location. You know, you look at it, it's just a yard. And like, hey guys, you know, what's wrong with this? Well,
Yeah, it seems like it should be easy.
yeah, but there's a couple of features in it that are apparently pretty tough. And also, as soon as people get good, you know, let's say this year we get 4 or 5 guys who get a 9. We're gonna make it harder. But you know, let's get a couple of people making 9s before we make it any tougher.
You're gonna float a cone out in the pond.
No, you probably have
Hovercraft time.
There you go.
Yeah, you might have to shoot a bridge or go down in a gully or something like that.
Going up in the tree.
Yeah.
Yeah, oh, yeah, there you go.
Yeah, I remember that there was a quicksand spot too.
Yeah, there's a couple of
marshes.
Yeah, and then there's always the pink flamingo, which is surprisingly close to a cone. But I'm stoked for this year, and I want to see what the remote guys are going to do. I mean, I know John's out there and Pat's looking at it. Are you coming in, or are you gonna? What are you gonna do this year? You gonna come visit us?
No, I'm gonna try to go with John and Tom, and
Okay.
we're gonna head down south to be somewhere near one of them. I think Tom's got an eye out for a place right now.
Cool.
That we can set up a remote competition and have 3 of us, and then I think John mentioned maybe another couple guy, got another guy or 2.
Yeah, that'd be
Yeah.
great.
Yeah, some guys from Waterloo are interested.
Cool. Yeah, how about you, Ted? Are you gonna come in, or are you gonna?
Yeah, I'm planning on making the trip to Dallas.
Okay, cool, great. Yeah. Okay, that sounds good. So we'll see.
Yep.
And I know Mike's over there smiling. I know he's got something up his sleeve. So we'll see how it goes.
Yeah, well, I just plan to manually drive mine just for fun. It's not going to be automated by then.
Oh, you'll get one. You ought to get it down to where you get at least 1 point and get your mug.
I'll try.
You're going to do it with the Robo Columbus bowling ball robot, where it just kind of rolls like a ball robot from
You know,
coast
just
to coast?
just
Oh, you
roll
said
it,
the full size
roll it down the hill.
Probably getting down the hill wouldn't be too bad, but getting back up, boy.
It'd be stopping after you go down the hill. Yeah.
Mhm. Yeah, cool. Well, is it time, guys?
It's
I
time.
think it's time.
Okay.
All right.
All right.
Night all.
We'll see you guys.
Bye.
Thank you.
You that are local, come to the thing on Saturday. Bring some crap so that we can rate it. Okay. And it'll be fun.
That'll be good.
Yep.
Yeah, and Doug, nice job on the. Oh, he left. I thought he did it, or whoever did a nice job on the meeting picture on the invite.